everyone. Thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome Chris Dossman back to the Weaviate Podcast. Chris joined on the 30th episode of the Weaviate Podcast alongside Weaviate CEO Bob Van Light and Chris's co-founder Marco Bianco. At the time, we were discussing your work with FAQx, and ChatGPT had just come out, and we were just like trying to wrap our heads around it. And now here we are, roughly a year later, and you've created just one of the most mind-blowing examples of DSPy that I've seen. I think obviously people watching maybe know that I love this DSPy framework. I just think it's so exciting. And you've implemented self-discover in it. And it's just such a future-looking thing. Chris, I'm so excited to welcome you back to the podcast and discuss where we're headed with AI technology.
Absolutely. And thanks, man. You know, it was a real surprise when, as I was trying to prepare for this, I looked back in our earlier podcast and YouTube. I know I was like blown away that YouTube claimed it was like a year old, because it feels like, honestly, it feels like a decade at this point. There's been so much going on in AI, so much going on with the frameworks. I'm really, we're talking about DSPy. I know back then it was LangChain. So I'm pumped. I'm excited. The self-discovery thing was a really exciting sort of like tutorial project to go into and learn a lot about what's going on with DSPy. And I'm glad to be here with you and discuss a little bit about that and sort of what we've been up to since then.
Yeah, amazing. I think maybe even before we start with self-discovery, I mean, yeah, definitely I'm super proud of how our first podcast was the 30th podcast. And we also had Charles Pierce, who was the second, come back to the Weaviate Podcast. And I remember also, I rewatched our podcast and preparing for this. I remember at the time you were describing how you were retrieving from government information to do kind of RAG with information about how do I get a visa or things like now. I think now people would be like, oh, of course that should work a bit. But at the time when, you were describing it, I thought you were so ahead of the curve with that. And as you mentioned.
Oh, no, absolutely. I remember the first conversations I had with people at Weaviate. I think I was talking to, it's not Bob, it was a Byron. I was talking to Byron, and Byron, I described it to Byron, and he just had a confused look on his face. I don't know if he really thought, when we first met up, it was I think 8 months before or 6 months before we had our Weaviate call, whether he thought what I was describing was even possible. But, it ended up being, it wasn't called RAG back then, that's for sure. I don't know what we called it on the podcast, but it was definitely an exciting time. And it was, originally See, the problem with the government websites and stuff back then was, and still now to this day, is that they don't really have, they're not up to date. For the top cities like New York City, where I am based right now, definitely you can find all the information you want. It's always updated, and it's something that's easy to navigate and get the information that you needed. But if you think about some place in Kentucky that has 50,000 people, it's not the same. The websites are out of date. The links are broken on this website. The number was updated years ago and no one bothered updating it. So it was a real tough challenge back then to find that information. And we did use GPT-3 and early versions of RAG in order to not only verify, but publish at scale for every single place in the United States, all of this verified local essential information. That's still there, that's still up. But I think when ChatGPT came out, and if you go back to the 30th podcast, you can sort of see not just the fear and excitement mixed together. I'm not sure what you call that emotion, but it was that, and we're looking at this crazy new technology coming out. I think we decided as co-founders, me, Marco, AJ, and Michael, the guys who were originally working on FAQx, we decided that we probably weren't going to be the guys to do it. We had launched something called Marianne, which was essentially ChatGPT, but connected to the internet and our local essential verified information. So it was you think of it like an early Perplexity or something to that effect. We looked at it and we thought, hey, are we really the guys to be able to do that the best in the world? looking at our backgrounds, looking at what we had done before, looking at even our like what we wanted to work on, we thought maybe we weren't the guy. So we sort of pivoted. We had built this crazy technology. What else could we use it for? We have a ton of experience with marketing. We've spent personally on the team, on the co-founder side alone, we've spent over $200 million on ads over the last 10 years. So we have an incredible amount of experience there. And we thought, hey, given this founder market fit, let's use this amazing technology and build something that will be the best in the world at. And so that's what sort of where Dicer came from. But still at the very heart of Dicer is RAG. Essentially it's a RAG and some other sort of interesting tricks in order to get like the performance that we do for what we're trying to accomplish.
Yeah, there's so many interesting things in that, and then I think let's continue on Dicer. But sort of just for me parsing it, the verified local information thing to me is so powerful. Like I'm fascinated by using these systems that use, say, the you.com API, or I think Perplexity also offers their web search as an API. I haven't personally used this. I can't personally testify to it, but using like these web search APIs with Weaviate, and you kind of have like your private vector database that you curate. And I kind of like that, like, the FAQx team, say it's Brooklyn information, right? And you've curated it so it doesn't search all of the web. You've kind of like narrowed the space and just kind of setting like information retrieval.
Yeah, and it's not just that too. It's also because, again, for places like New York, you can probably find it on the web. But for other places, smaller places, the web is actually a source of misinformation. Like I think it's still the case, but if you look for the non-emergency phone number for Sarasota, Florida, in Google, for in Perplexity, in ChatGPT, and in any place really, you'll get the wrong number, because the number that's listed on the site is wrong. It's not the correct, not the updated one.
Yeah.
So actually, I would say it's a sort of hybrid machine, human plus AI scraping and verification in order to do that. We actually, it's not active anymore, so I wouldn't speak to the validity of some of the smaller areas within the FAQx database, but we could turn it on. And what it is literally tens of thousands of people all searching for the data to make sure that it's verified. So it really is this human machine hybrid. And that's how we got to like the level of accuracy that we did. We couldn't do it with just RAG alone. We couldn't do it with just like the search APIs, even when we limited it to just like .govs or something like that. And we take the same approach too with all of the AI products that we're building. We really think that the future of AI is not just AI, especially with hallucination being like a fundamental part of these systems. You'll always need that human AI hybrid system to get 100% or get as close to possible as we can possibly get.
Yeah, I think that's a super strong case. And yeah, Brooklyn was a terrible example of this. But yeah, so there's one more thing before continuing on your entrepreneurial journey, which I think is just so fascinating. Definitely someone who, I hate the borrowing of in the trenches from like hip hop into into like AI and tech, but you're really someone who's like building and trying these things there's one more thing that you mentioned in your opening statement about sort of like our reaction on the 30th podcast to ChatGPT, where there was almost like this fear of it. Like, because when ChatGPT came out, I also, talking to ChatGPT, I was like, wow, this is like almost terrifying. And I guess the reason I want to talk about this a little more is last night I rewatched Ilya Sutskever's TED Talk, where he's explaining like what drew him to AI, how it can have such profound impact on society. And now I think kind of coming back to DSPy, your self-discover, maybe we haven't introduced it yet 9 minutes in, but like this idea that the AI is going to search for its own reasoning and then compile itself, like the AI is just becoming so powerful. So I just really quickly, before we continue with Dicer, I just wanted to maybe get your sentiment on, how your, our initial reaction to ChatGPT. And, I think we shared that moment together because that was also from like the four of us recording an hour podcast. That was my deepest reflection of it at the time as well. How are you now feeling about DSPy? Do you have a similar reaction to it?
Well, DSPy is, and I don't want to throw LangChain or these other frameworks under the bus, because I think it's just a completely different beast, almost, right? It's like you're programming with large language models. I see it almost like this is what I wanted LangChain to be when it first released. Like I think we all got excited because we were like, finally, LangChain's going to make it easy to build on top of these systems and to build in ways that sort of abstract away some of the worst parts of working with large language models, prompting being a big one, right? And so when I look at it, I think I see not fear. I feel excitement and really awe at what people are building, and that these new abstractions can come out, even though DSPy is not funded. It's a university PhD project. These great new abstractions can come out and actually help make the people who build with these systems lives much better, but also fundamentally improve the systems, improve the products that are built on top of this. Because when I look at DSPy, I see something that forces you to think in the way I think the top people in LLMs are actually working in, right? They're thinking from a perspective of what are my inputs and what are my expected outputs, and then how can I develop a system that will give me, the expected output 99% of the time, and not having to be like please, 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 adding please, please, please to the prompt, or like trying tricks like converting JSON to YAML, or like realizing like if I ask the LLM for numbers, it's worse than if I ask it for words that represent numbers, and that's a big one. So the I'm very excited for it. I'm even more excited for it after I did that first self-discover system, and I didn't even use the fancy optimizers. I played around with some of the optimizers, but Omar comes messaged me on Twitter, and he's like, "Hey Chris, you think you want to try some of the more fancy stuff? I see you built your own examples." Obviously, I built those examples to make it easy for people to understand what's going on behind the hood. So it's just like all spelled out for you. And it hasn't been enough time. I'm excited to spend more time. I'm excited to contribute maybe a little bit as well to the framework, and see it grow, man. It's been exciting.
There's just so many amazing ideas in that. I think maybe starting with the LangChain comparison is a fascinating one. I think a lot of people are going to really be interested in this topic. I mean, because it sounds like the compilers and the optimization, to me, there's kind of like two things going on with DSPy. Like there's already just the programming model and the structured output parsing, and we had Jason Liu on the podcast, an instructor, and I think he's absolutely thinking like he's on top of the curve on that output JSON. I listened to Arnav present DSPy assertions at the ML Ops community. So that kind of just the programming model defining the forward pass logic of how these prompts interact with each other. And then there's the structured output following and how you enforce that. I almost see that as like a different thing. And then the compiling is like a whole nother can of worms. So my perspective on LangChain is I do think they'll be able to interface the chains that they've come up with so far with the compilers. And I mean, the way that Omar puts it is that LangChain and Llama Index is kind of like the hugging face of these chains programs, whichever you prefer, right? And they have these pre-built templates, like I think Chat Vector DB from it's been a while since I've seen the particular naming in the code base, but like it has this kind of like recursive summary on the chat history, and so that would be kind of my perspective and on LangChain.
Yeah, it's kind of just because it's like PyTorch and CUDA, right? DSPy is CUDA. I mean, that's a very bad analogy because they're very different. But I like DSPy because you get closer. I don't like using a pre-made chain. I really don't. I get why you would if you're just trying to build a bog standard, chat to your PDF or something to that effect. But actually going through the thought process of even just building the examples helps you understand the problem in such a different way. And oftentimes, if you just reframe the way you're thinking about a problem, you can cut out a lot of the complexity, or you can reduce hallucinations a lot by actually understanding what are the IO input outputs for these models, and like what are the outputs and what are the failure cases within that prompt regime that you're trying to build for in a way that you don't get with LangChain. I see a lot of the issues being propagated by LangChain because it's just like these models are finicky, super finicky. These systems are super finicky. If you're not like close to the metal, you won't actually understand how close or far you are away from making it into like an amazing experience or an amazing output. So I think that's really important. I've always found a lot of success in of breaking down, like if I'm building a pipeline with LLMs, I break it down to as small as possible parts in order that really helps with reducing the hallucination. Also having really great examples, not too many, but just enough, such that you get outputs that are expected and outputs that are high quality and don't have hallucinated text. If anything, I on the 30th podcast, I remember Bob asked me, "What's the one thing if I like had Sam Altman, or if I was talking to OpenAI directly, what's the one thing I would ask them for more? It's more context. Give me more context. Give me a bigger context window. OpenAI. I think I'll go back on that now. I think that's useful in certain situations, like I have access to Gemini 1.5 Pro, and so I've been using 800,000 token context, and it's great for going through a repo and like helping me update something in the repo, or asking a specific question about how it's implemented within the repo. But for if I'm like thinking about production, and I'm thinking about like a recent project of mine was to download all these YouTube videos for maybe financial channels, basically, and then retranscribe them, and then go through the transcriptions and find mentions of public companies and the sentiment for those public companies. And doing that project, I realized that the best performing, I like tried, let me just put the entire transcript into GPT-4 125 K context window. No good. I wasn't getting the accuracy I needed for the clients that I was working with in order to make that work. And I found as I went smaller, the hallucinations dropped significantly, and I was able to get a lot better quality output. So, there's just some thoughts there in terms of context and going back to that. But
yeah, well, that's obviously super powerful nugget. I think there was that Lost in the Middle paper. Greg Camrat has like an amazing, I think he calls it needle in the haystack, his experiments on it. And
it's kind of a contrived synthetic data set. You still when you're actually building it, you really do still see the hallucinations happen. It's very frustrating. And I think we need a better needle in the haystack test, or like a needle in the haystack test that is more indicative of like real workloads. Because I see those, and I see the 100% recall across all of the things. And I'm just like, I wish this was true. I wish these green graphs were as true as they seem, but sadly, not quite when you're working with real data and like real use cases.
Well, that's a huge category of, I think, a lot of these AI startups. We had Ragus on the podcast where their focus is LLM metrics, and Arise AI has done a lot of amazing work here. And yeah, just trying to come up with how are you going to evaluate hallucinations. I agree. I think that's a massive thing. Maybe one other thing I want to add with this, with the DSPy story, is with it kind of, you brought up perplexity earlier, and DSPy assertions has where you can kind of make sure that the text cites the text, and then you can kind of have like this retry prompt if it doesn't. And maybe if we could zoom in on this, then the retry prompt a little bit, we'll just kind of continue on our topic. Yeah.
Let me I'll borrow from Jason. I met Jason in real life in New York once. Really smart guy, and I did watch his podcast with you guys. And I like what he's saying, really. Verification is verification. Like, if you can verify the answers that your LLMs are outputting, you should verify them. And I'd like that DSPy is building that in with assertions. Unfortunately, I have not been able to try it out yet. When I was building self-discover prompting, it wasn't out yet, and like the docs were completely empty. I think that's changed since, so I'll definitely revisit it. But verifying, if you can verify the output, you can get a lot better end user experience, and know your quality outputs. And so things like that, things like going through the context, or verifying that this particular thing is being said within the context window, are very powerful tools, and something that you want to look forward. Also, if you're doing that, again, it's easier to do with a small amount of context than it is to be a giant amount of context. So, I don't think RAG's going anywhere soon. There was a little bit of a thread on Twitter about that recently, about how RAG's dead and this and that. But at the end of the day, people build these software, and we can't. I don't know about you, but I can't grok a book's worth of context in order to understand whether or not the output is good or bad based on it. So, and again, it goes back to DSPy and why I like it so much. It forces you to think about the inputs and outputs from the beginning. You can't necessarily start building with DSPy unless you have you can't use you can use it if you build your own examples, the compile function, right? But that's great. That's because I want people to think. I want the engineers who work on my team, who are also building on this, to think about those examples before they even start prompting, really. So what do you care? What is actually the goal of this system or this pipeline? And DSPy forces it, in a sense, in order for you to use the higher level functions like optimize or compile. You can obviously build your own examples, which is fine. But it makes it easy for you to turn a data set that you have into examples too, which is really great. The compile stuff is really interesting. I wish I had more. It's really interesting from the point of view, one of the big things I remember spending a lot of time on is building chain of thought examples that I would use within, because I'm never doing 0-shot prompting. I always have either 3 or 5-shot prompting. Generally, sometimes I go much higher, depending on the use case. But it's really time consuming to try to develop quality chain of thought prompt, because you have to go through and actually make it. DSPy just does it for you, which is great. And if you throw in a verifier, you can even verify that it's actually the correct answer before it throws it into the example pool. So that's all fantastic. And that alone would be worth me using DSPy over everything else. But then when you come to the optimizers and actually being, I have this data set of 1,000 user sessions. Let me just throw them in. I've just made a bunch of examples. And I think, I haven't tried this one particularly, but I'm pretty sure he's got some of these compilers that actually will pull the examples that are most similar to what the actual task, the K. I think there's the KNN optimizer that will do that. I think there's a couple other ones too. I'll have to check in. Wish I had more time. Building a startup takes a lot of time, so you don't have too much time to develop on new frameworks. But they've definitely got my attention, and I'm going to be building a little bit more with it. I'm actually in the middle of a refactor right now, so we have just so many pipelines at Dicer AI, and I'm refactoring some of the base level pipelines right now to use DSPy. So I'll be releasing more and probably a couple more open source implementations as well, using some of the other optimizers. If you're listening to this, Omar, I heard your message. I'm gonna go check out those other optimizers.
Awesome. Yeah. So there's just so many ideas again in that one. And I think the one that I kind of want to stay on, I think now would be a good time to kind of start unpacking self-discover, because I think if we could kind of backtrack that you mentioned the bootstrapping chain of thought examples. So the chain of thought, it modifies the prompt that you're trying to do it to also add, let's think step by step, and then whatever the output is.
Yeah.
And you don't want to have to write those rationales yourself.
Or I never really wrote the rationale. I would just like pass it to the art, but that's wasted work. Why am I like copy, click here, select this, put it to GPT-4, switch tabs, go back, it's a big pain in the ass. But you need it, especially, people say chain of thought. There's also a lot of other different prompting types, which DSPy also supports. And all of those, you can bootstrap these examples to include whatever steps they have in it. I'm sure actually self-discover will probably be its own callable function within DSPy pretty soon, if it isn't already. You gave me a link to the Discord channel. If you're not on the Discord and if you're interested, please join that Discord. A lot of interesting people there, and I see a lot of activity of people building, and looks like one of them wanted to do a PR for exactly that, right? So going back to the bootstrapping and self-discover, I think it was released the 20th or the 22nd was the release of the paper, and I remember reading it and thinking, wow, this is just amazing. It's RAG for thought. It's RAG for thought. It does what would take like tree of thought. I'm not sure if everyone's familiar with tree of thought, but tree of thought is the one where you're basically running the LLM like 50 times, 60 times in order to build like a tree of different possible paths for this output to take, and then you end up choosing the one or you end up using the LLM to choose the one that's like most correct or least hallucinated. And it's it does do better than chain of thought, which is just a single call, but you 50x'd your cost for that one specific prompt. It's crazy. Self-discover, the innovative part about it, it's like, okay, well, that's really cool. I can query the large language model 10,000 times, and eventually it will give me the right answer once, right? Self-discover was really about, hey, we know that there exists a bunch of frameworks of thought that help humans answer tough questions, right? Things like chain of thought, right? Chain of thought or think step by step is a reasoning, like a type of structured reasoning that people can implement that would help in most cases improve the quality of the result. Or think creatively. If someone told you we have to think outside of the box, right? They're saying that because they want you to come up with something novel or different or new, right? So what self-discover is we have it's either 29 or 39. I think it's 29 reasoning modules, or these. Actually, I have it right. Can I share my screen?
Sorry, no. I think Riverside lets you, but Zencaster, we use Zencaster in the Weaviate.
Oh, that's a bummer. Well, okay, look. So we have these 29 reasoning modules. How could I'm going to just list out a couple of examples. How could I devise an experiment to help solve that problem? Right? That's a great question to ask, right? There's other ones like this. How can I simplify the problem so it's easier to solve? Right? Or let's see one more. Does the problem involve a physical constraint, such as limited resources, infrastructure, or space? So these reasoning modules are, it's broken up into 4 distinct steps, right? So it's like the select module. I have a task, and I have these reasoning modules. Which of these reasoning modules are going to be useful in solving this particular task? So you ask the model to output that. So the model will output maybe 4 or 5 different reasoning modules that it thinks that will be useful for the task at hand. And then after you've selected the modules, you then go into the adapt module stage. So these reasoning modules are useful, right? But they're not specific to the problem that you're actually solving. And so in the next step, the adaptation step, is where you actually take the list of 4 or 5 reasoning modules, and then you create actual, like, you make it relate to the task at hand. So I'll give you a quick example. We have this task. How many numbers between 1 and 2005 are integer multiples of 3 or 4, but not 12, right? So one of the selected modules was, what is the core issue or problem that needs to be addressed? And the adapted module from that would be, identify the mathematical pattern or rule that defines the set of numbers. Right? So now you've gone from like this original sort of general idea to that general idea or principle applied to the specific task in the adapt module. The third step, not the last one. The third step is to take those adapted modules. These are sort of like instructions on how to solve the problem that you're facing, and turn them into a step-by-step guide with a description and an action that you should take, but not actually trying to solve the problem. Once this, and I'll just keep on. I wish I could show. I guess you can just link to the collab that I made for this, and if you're really interested, you can go through that. Again, I made the examples. I didn't use the optimizer because I wanted to make the example so it would be really easy for you to understand it. So if you look at it, it's not going to be hidden away. Once you have this like sort of reasoning structured, which is this, step 1 through however many steps the LLM thinks it's going to take, plus the descriptions of the problem at that step, and then the actual action or the steps that the LLM should take in order to get it to an answer. That's all outlined out. And at the very end, we have the solver. So we take that reasoning structure, this structured JSON, and then solve for each one of the steps independently. And so at the very end, you end up with the LLM following the step-by-step instructions that are, in essence, from the very beginning, reasoning modules. All of this 4 calls instead of 50 calls, and much better performance than think step by step. Self-discover based on the paper is actually the best of any of the prompting techniques that are out there, irregardless. So creates a very quality output. Oftentimes the biggest challenge I found actually was that I used an LLM to validate that the answer that the LLM created was the same or correct as the actual answer from the data set itself. The challenge was the validator. The validator, even though like the LLM output would not be like exactly in the format, it wouldn't like. So for the big bench hard, a lot of which is the data set I used for they DeepMind use and I use for the validation of this, it has like a multiple choice questions from like grad students or something, grad student questions, multiple choice. So sometimes the answer is just like A, right? But then the answer that my system produces is the number of answers is 102 or 1,000. There's 12 numbers between this and so I couldn't build a verification system that would work appropriately, and so I even when I finally published it to Twitter, I just got fed up because I was like, I'm just going to do it by hand. Then I'm only going to do it for like 50 questions. It's not that big of a deal. So that's a very interesting outputs from self-discover. Very high quality, very simple, easy idea, and low cost. Better than tree of thought. And if you can figure out how to use LLMs as validators, at a level that's like higher than 80%, which is what I found, then you can see the results for yourself. They're very high quality. Oftentimes, if it is wrong, it's wrong, especially with math questions. It's wrong in a way that a person's wrong. Like it'll be wrong by a couple digits or something. So it was really good, and it's one of those kind of prompts too that you can add as a wrapper around any task or any prompt, actually, right? So that's why I'm doing the refactor, because I was like, oh, that's why I picked self-discover, because it's like, if I just make this work, then I know I can wrap this around any of the prompts and any of the pipelines that I have within this in order to get just out of the box better results, more thought through results. That's really exciting. But a potential is actually to, I might update the reasoning modules to include reasoning modules that are not as general, maybe a little bit more focused within the domain that I'm using within. We're doing it for marketing reasons. So I could probably add a couple marketing specific reasoning modules in order to improve the performance there. But priority. There's a lot of work to do, not a whole lot of time, sadly. So priorities.
Well, that's the thing that makes me just so excited, is how it can take. So I was listening to Demis Hassabis, the CEO founder of DeepMind, on Dwarkesh Patel's podcast, and the question was, so what about tabula rasa, like blank slate learning? And he's explaining how, some people at DeepMind, they're certainly still working on that RL from scratch, learn it all from scratch, but there's also just so many priors to, prior knowledge to build on top of each other. And this is such a fascinating intersection of priors, because you have this prior on the chain of thought, like, let's think step by step, let's think out of the box if you want creative outputs, or let's think to calculate an answer. And then you stack this with your task as you're compiling it. So you generally have this signature, like, your task is to, or like, write a marketing copy for this blog post. And then it has the inputs and the output description, and then it would have input output examples, and it would have like the chain of thought. And now you have that chain of thought in the examples, and it's going to be adapted to the marketing thing by the way you're compiling it with your data. I hope that's a good description of it. But yeah. Then this kind of like, so my question to you, so this kind of like, so now you're searching for the priors. Like, you could either add chain of thought to your prompts, you could add the calculate, the let's think out of the box, and we'll just keep it. And as a meta comment, when I was reading your notebook, I was just imagining you writing out all those descriptions. Did you write all those out by hand?
No, I was lucky. They actually included it in the appendix of the paper, so it's just like copy paste. But
then I can imagine Clockley writing it. But yeah, so I mean, okay. So my question now is: do you see self-discover as being? I don't see it as being a module. I don't see it as being another DSPy chain of thought. I see it as being a part of the compilers. Yeah, because you have.
I think at the end state, this is probably something that should be done in the model itself. There was a really interesting paper I read recently that sort of looked at what's the model actually doing when it goes from when it's trying to answer a question in Chinese with Chinese, right? They were like, does the model think in English? And they kind of prove that it does, in a sense, right? It's thinking in this sort of abstract sort of thought space. It's not quite English, but it's more similar to English than it is to Chinese. So what they found is it will go from like the question input is like Chinese, and then the model's thinking in like this pseudo English, and then it will take from pseudo English back to Chinese for the output. So it's not thinking in Chinese. I think that there's a lot of really interesting research left to do about exactly how things are happening in the model, and then finding out finding the ways in which, like, what is what is the model doing within its head when it's doing chain of thought, and then applying that for every single thing. What is the model doing when I do reasoning, this reasoning structure? Can we apply that within like the weights so that it does it for every single prompt that comes its way? I think that's or another interesting research direction to take is, why can I spend more compute on specific tokens and less compute on other tokens? Right? It's sort of analogous, like another way of thinking about that same. Can I think more, or can I force this thinking or force this computation in a way that it's like leading to better results all within, because doing like calling the LLM multiple times, that's like, it's a hack, right? And it's a hack that kind of works, and it works really well for a lot of cases, right? We were able to build ChatGPT connected to the internet 6 months before ChatGPT came out because we were hacking with RAG, right? We were messing around with it. We didn't build a better model. We were actually using a worse model than what they probably used for ChatGPT. But because we like figured out this engineering hack, we were able to get more from it. And that's what I think self-discover is actually. It's an engineering hack to build a better training data set for DeepMind, for Google, right? Because if you think of it, they're at this point, we're probably all of the major companies are using huge amounts of synthetic data. How are they generating that synthetic data? They're generating with these models, right? So a little bit, I went a little bit off topic there, but I think that's the way we should think about some of this. It's like the reason they released it now is because they've been using it for the last 8 months in order to generate enough really high quality training data so that they can then train, 1.5 Gemini 1.5 Pro, right? And they're just giving it to us now because the lawyers say it's the lawyers and the business people say it's long enough. It's not a threat to us anymore, and we're sort of here, at the doldrums, getting some of these gold coins that they're dropping to us. Jack Clark's put it really well on his newsletter, Import AI. The only reason we have Gemma, I think I'm saying it right, the open source model from Google. The only reason we have that is because these giant companies are fighting each other for like mind share, right? And we wouldn't have it if it wasn't for that. So, anyway, so yeah, in the model is going to be better to do that. But going back to the original question was like, is this not? You mentioned this is like the function, or is it the compile step? I'm not sure because it is like a multi call to it. It sounds like I just need to spend more time with the DSPy. I probably should spend a little bit more time in the library and see where it fits. I wish Omar was here to tell us. He's probably screaming. Wherever he's watching this, he's screaming.
Yeah. Well, I think that what you're saying about the kind of latent space model thinking, or like, latent space and model think. I think like if you want to anthropomorphize the system and say it thinks, inspecting its latent space, obviously vector databases, we've been like super big on vector representations of objects, and instead of having it always produce text to have like text transformation graphs, you can maybe interface the latent representations from the model. And when we had Luca Buehrer-Kellner on the podcast who came up with LMQL, which I had personally learned about like maybe 3-4 months before I learned about DSPy. And so in the podcast, in that one with Luca, we had kind of like two halves to it. The first of which was, basically just like this constrained sampling thing that you talk about, like only like one way to have it, have a properly formatted JSON is only let it output, curly brackets, or, so you kind of deeply integrate the structured output with the decoding of the model. And I think SGLang has a lot of ideas like this, and we get a lot of comments on our DSPy videos so far of like, how does this differ from SGLang? And it's that idea of interfacing the latent representations in these chains. I mean, Retro from DeepMind, where you have it's like RAG, but not with the text as input, but the embeddings as the input.
Yeah.
And so there's probably opportunity for like in-memory vector processing, and vector databases are probably more so like that long-term using disk, that kind of like memory trade-off thing. But yeah, it's all just super interesting. And I guess maybe, I don't know if it would be worth further going into that idea of like, okay, is self-discover a DSPy module, or is it a part of the teleprompter? I think all this stuff can be wrapped in, like the same hyperparameter tuning stuff we saw with like weights and biases, all this search stuff, that you have that kind of opportunity. Yeah, maybe distracted. The idea of this latent representations is so profound. Yeah.
Yeah, and that I wish I remember the name of the author. So you guys, I'll share a link. Hopefully, you can put it in the description or something for that paper. But the paper that sort of they built this tool to look into the mind, well, to look into the LLM and see what's actually going on. And I think there's so much research to do in thoughts, the thought space or the latent space, as you said, of what the model's doing inside. All those billions of parameters, what's going on in there? How are things moving around? That's I think when we look more into that, we'll definitely find even better ways to make sure that the output is high quality, that it's well thought out, that it's something that
maybe
a person would output.
Maybe even coming back to our earlier thing of like, are you scared of these systems at all? I might be kind of scared of a chain that's totally latent space to latent space. Like that to me sounds like something that would be uninterpretable. Like if we're talking about how can AI become like this totally terrifying alien intelligence if it is processing things in latent space rather than having to do text.
Yeah, that's not wrong, right? I think that's correct. Goodall's incompleteness theorem states that any set of rules that you can come up with to describe like phenomena is going to be incomplete. So language is incomplete. Is latent space incomplete? I don't know. Probably, actually. It's still a construct. It's like vectors that are being passed around. I think in terms of interpretability, language is going to be better. I think in terms of scalability, doing it in the model is going to be much better, right? And I'm not afraid of AI. I'm not afraid of what's coming. Because it's all trained off of like human. It's all very human. I'm very surprised, actually. If I had a bingo card, LLMs wouldn't have been like the way to get to these intelligent systems or these very powerful systems, right? It all came like I thought it was going to be like a AlphaGo style, chess playing system, very alien in its play, because it's like it's played chess a billion times, so it's like uninterpretable to people. But it is exciting to see that the AI that everyone's like rallied around right now is very interpretable, is language based. I don't think it'll be like that. I don't think it will be like that for very long. I think we're going to see a change. You can already see it with Sora, right? OpenAI is very big on the idea that these video models are probably they will offer a better world model than LLMs, and I agree. Part of the interesting engineering hacks that we looked into early on was using LLMs with other tools like simulators in order to ground the output in like reality. So it's like you can imagine like an LLM, a tool using LLM could call on a simulator to actually run something before it like created the final output or answer. So it's getting there. I'm a little bit worried, but I made a prediction on the last podcast that by 2030 there's probably going to be like 1 trillion agents, like intelligent agents, running around doing stuff for people, and I kind of sort of welcome that future. I'm a little bit apprehensive, but it's all based off of human language. It's very human in that way. So I don't know if it'll go off the rails. I'm not too worried. And even if we do get like some weird RL, super AlphaGo, AlphaZero style, machine intelligence that is kind of like detached from reality in a way, I think at the end of the day, what we'll find is that it's still just a tool. And all tools need people to use them. You can't, you can use a tool for good and bad, but it's still the people that are there making the decisions and choosing. There's some interesting stuff with agents coming around, but good luck getting an agent to do anything useful for more than a couple steps. I'm still waiting for the agent that really works really well. And I don't know if that's a fundamental issue or if that's an engineering issue that will be solved over time. But just keep your eyes peeled. Listen. Keep up to date on the latest technology, and just try to use it as best you can to help solve real world problems. Right? Solve problems that people care about. Solve problems that help make people's lives better. And I think we'll have a wonderful future with AI. Not the dystopian one that I think a lot of doomers like to think is going to happen. Paper clips and all of this stuff.
Yeah, well, I agree. I guess on the first thing of trying to make agents reliable for more steps, I'm seeing I listened to Harrison Chase on the Redpoint podcast, where he's talking about the state machine abstraction and how it's about trying to maintain state between chains, and I think maybe that is how we have these how do we actually have the planning head, the chains, the multi-step processing? Maybe that has a role in it. But aside from that, on this tool thing, and I think coming back to Dicer AI and super curious to learn more about how you're using these systems for marketing applications. I also think about marketing a lot at Weaviate, and so Eric had put together this demo of doing questions to blog posts with DSPy. And then the same day, Omar had even sent us a message oh, we have a system that they've called Storm. And so Storm is it's an 8-step processing, generating entire blog posts. And so it's to me, surely marketing, content creation, this podcast we're having now, it's I feel like this medium is going to be sort of safe from this because it is very human. It's here's what Connor and Chris think, but content, code documentation, probably code itself, is all this ability to generate long form content is, I think, super profound.
Yeah, and it is. I saw Storm. I'm going to be using Storm. I love Storm. For on the marketing side, and what we do at Dicer, it's really we're trying to, and it's funny, you kind of hit on it too with the developer stuff like documentation, pull review requests, automation. Right. Shout out to Hunter at Ellipsis Dev. He's working on that right now at YC. He's doing great. All of these things are things that people don't want to do. Do you think I want to sit around an office and write a blog post for every single one of my fact questions? No, I would actually. It would never get done. It would be sent to some Upwork person in a different country, cost less. Go do the task. Leave me alone. Let me work on this other stuff. What I find is that the first things to get automated are all the stuff that people don't want to do. It's so hard to find people who are willing. I have. I'm a serial entrepreneur. Dicer is my baby, but I have other products. Some of which 10 million monthly active users on some of the products, and it's still difficult for me to find reliable development for those products. Right? I can't wait till AI comes and actually does the dev, because at least then I'll be able to make progress on it on a daily basis, instead of trying to beg, borrow, and steal to get anyone to help with products that actually have users, right? So, on the marketing side and what we're doing there, that's exactly the same thought. It's again, it's the human AI symbiosis, right? What are the things that we know what marketing teams are doing basically is you're looking at your data and you're trying to see what is working and what is not working, and then do more of what is working, plus throw in sprinkle in a little testing of new ideas in order to find different angles of attack. So what we've done at Dicer is, our pipelines basically automate all the shit work that people ordinarily wouldn't want to do. We are looking at every single image, every single piece of copy, in relationship to every single other piece of copy, and the targeting of what you're doing, and how much money you're spending towards it, and then deciding based on that, what are the insights? What are the things that actually seem to be working about the images? Is it the fact that you have a big call to action right on the image? Is it because the subject of the image is just a woman in a red dress that seems to be hitting really well because your audience is mostly males in college or something. So we're looking at the all of that data together in aggregate, generating these insights in a way that a person wouldn't really normally be able to do, and oftentimes wouldn't want to do, because you're literally staring at spreadsheets for 20, 40 hours in order to make those same judgment calls yourself. So when we're building systems, and when I'm building systems, I always try to think like, let me automate the stuff that people don't want to do. And if I can automate that, I give them more time to do what they do want to do, right? People want to spend more time being creative. They want to spend more time working on passion projects. They want to spend more time, tweeting. They want to get more followers on, being smart. They want to read more papers, right? And that's how really we're thinking about it and how we're building towards it at Dicer. And I think that's what's going to do really well in the short term in terms of businesses that come out from these technologies. So, obviously we're still very, again, I can't believe ChatGPT came out like just a little over a year ago. Well, no, that was more, that was GPT-4. ChatGPT came out, the 2022?
Oh yeah, I think 2020. I think it came out. Eric and I always disagree with this. I think it came out right after NeurIPS of 2022.
It's like November or something.
Yeah,
right?
yeah.
October, one of those. Still amazing.
Or I guess before. Yeah.
How short it's been. The timelines have been so far. We're still so early. I'm really excited to be using DSPy in what we're building, and I think there's going to be more. Like you said, right? The other frameworks that are out there. Well, how is this different than this other framework? If anything, it's more of a testament to this AI stuff. Now everyone can build. Everyone can build. So there's probably going to be a framework for every flavor of work that exists out there. It's exciting times. Very, very exciting times.
Yeah, I'm just so excited and inspired by what you're saying. Like, I think even right when we hang up the podcast, I'm going to go work on this like pull request to docs. Do you think you have like the Weaviate documentation is like this folder full of markdown files, and you can retrieve from it and write new docs with all the pull requests, and there's just so much to this. It's hard for me to even like try to say what do I want to say next on the podcast, because that idea of the automating this kind of tedious writing work in software business, so many examples like that.
Yeah, and it's important too, because the documentations it's probably going to be helpful for future AI systems that maybe will do the work of the devs, developers, so on. We're still. I always like to say, and I know we're getting towards the end, so I'll leave off on a high note. And I know things are moving so fast, and everyone gets kind of nervous and scared when they see the new drop. And I'm sure when GPT-5 comes out, there's going to be a new wave of like anxiety and stuff. But electricity took factories around 10 years to like. They had electricity in their factories. They were using it, and they thought, oh man, this is going to make it so much more effective to build stuff. And it took 10 years for people to actually learn how to, like, people, right? Because at the end of the day, what is this all for? Why do I have a MacBook? Why am I making a podcast? It's because people, man. The world exists for people because it's us. Right? We're doing it all for us, for other people too. You're not working for some abstract like principle. You're working because you want to feed yourself. You want to feed your family. You want to make life better for the people around you. That's what really matters. We're not going to get replaced. People matter. It's going to take 10 years for us to really figure out how to use what came out for ChatGPT. Like the majority of people, it's going to take 10 years for the majority of people to know how to use ChatGPT. It doesn't matter that there's some like alpha infinity, super AGI that's released in 2030, people are still going to be trying to figure out how to use ChatGPT in the world, right? So there's plenty of time. Don't have anxiety. Get up every morning, feel excited for the fact that we can now do so much more with less, and build just every day. Wake up and build something. Make life better for yourself. Make life better for other people around you using the tools that you have available. And we'll, in 20 years from now, 50 years from now, we'll hopefully be sitting. Me and you can get on another podcast. But this time on an orbital station, or on the moon colony, or in Alpha Centauri. Who fucking knows? All right, I don't know. I don't. Can I curse on this podcast? Should have asked that before we got on.
I probably in the history of the podcast, I'm sure we'll have to index it all and search. Yeah, I love everything you're saying. It maybe a moment that always stuck in my mind for me with my history of Weaviate and learning this AI business, especially studying like Bob Van Light and Eddie and Dillacker at Weaviate. One time when we were in Croatia, I was talking to Bob, and Bob, like, he's a pretty technical CEO. Like Aiden Gomez, I know he did a pull request to DSPy, and there was a Twitter about, like the CEO. He said I'm still technical, and I thought all that was great. And so I was expecting Bob to maybe say something like, about like maybe his head is like, I just love making HNSW faster or increasing the developer experience even further with better APIs. But for him, it's like about the people. And I think exactly that is, as I've been learning more, learning people, learning what they're working on, that should be the core driver rather than just technical interest.
Yeah, you really, Bob's a special guy. I'm gonna gas Bob up here. He's a special guy, man. It's very rare you see someone with a diverse background like him. Like really big into music, really, really big into music. Not just like, oh, I studied it for a bit, but actually like he made it his life for a while. And then to also be so technical, so amazing. You guys are lucky to have Bob as a leader over at Weaviate. And he's a nice guy too. Whenever I see him, he gives me a big bear hug. It's the best. It's like, I can't wait to see this guy again.
That's a super funny one, because I started doing that too.
A big bear hug. Oh man, I'm afraid when I see you in person, dude. I'm a smaller guy. Don't crush me, please. Very endearing. It's very endearing, dude. Right? And it goes back to people are what matter. So,
yeah.
Anyway,
awesome. Well, Chris, thank you so much for joining the Weaviate podcast. Returning to it, self-discover this implementation in DSPy. It's just so fascinating. I really encourage people to. Notebook will, of course, be linked in the description of this video. I can't wait to learn more about what you're doing at Dicer AI. Everything we talked about using DSPy for marketing. It all should just be so exciting. Thanks so much, Chris.
Thank you, Connor.